Assalamualaikum warahmatullahi wabarakatuh. Today I will present on PSM1. My title is Derivative of Energy Harvesting from Raindrop using Piezoelectric Technology for Low Power Application. So my name is Ahmad. My metric number is CN200170. My supervisor is Dr. Noain. So this is my table of content. First, introduction. Chapter 2 is literature review. Chapter 3 is methodology. Chapter 4 is primary result, and chapter 5 is conclusion. So for chapter 1, my background study. So I want to explain about my piezo effect. So this first, the most common kind energy concept is for the production for electricity. With the application of technical the piezo effect lost energy can be converted into electricity. So next is piezo material has the ability to transfer the force asset by moving individual into electric current. Next is harness of kinetic energy of raindrop. So my project background is kinetic energy from piezo using raindrop. So next is problem statement. For problem statement, first, one of the particular source of energy rain, the common way generate energy for this source is by utilize dam system. Second, otak is very effective, and the electric energy generated by it promising, but is not applicable to implement everywhere, especially is remote area. So this project is will make the rain of tile and the piezo material of apply the pressure. The rain can make a pressure at piezo. Next is the voltage generated across piezoelectric tie sent into a battery when they recharge the battery to the supply DC load. Next, this research objective. First, to simulate the circuit of rectifier and boost the integrate with the raindrop piezo generator. Second, to develop a model of the raindrop piezoelectric generator and working prototype of energy harvesting module. Third, to analyze the relationship between size arrangement of piezo transduce and the output product from the raindrop generator. Next, scope of research. So first, the energy harvesting using around piezoelectric transduce this that install horizontally with the raindrop. The project M produce a simple prototype of raindrop power generated by using multiple number of piezo. So I will use 25 until 30 piezoelectric for the raindrop piezoelectric for the piezoelectric exactly. The raindrop power generate major component is of water pump, water tank, piezo plant, and raindrop maker. So the major component consistent of the piezo plant, AC to DC rectifier and DC to DC boost converter. Each piezo is diameter is 35 mm. So I will talk about literature review chapter 2. So this my previous project as I have a 5 previous project. First previous project is blade rotation piezo energy harvest by hydro application of ultra and wide range flow rate. So for the first previous project one, they are big blade, then their potential for the mechanical energy of ultra flow to be intermittently translate into the rotation energy of the typing bucket can be released the passive alternate to center gravity. For the second previous project is performance assessment of a piezoelectric rain energy harvest. So this second previous project, the mechanism that direct raindrop into scenery, breaking them up into individual drop of water. So their improved technique is to turn random raindrop into the piezo beam ideal location. So the third is piezo rainfall energy harvesting performed by an advanced Arduino based measure system. So this project is for they create electricity from rainfall, but they did quantify how much energy is produced. So this is a research project. So previous project number 4 is a method to estimate the transit fluid pressure of a piezoelectric inkjet printer using system dynamic analysis. So their previous number 4 is their use inkjet printer and build piezoelectric into inkjet printer. Number 5, a leaf mimic rain energy harvesting by liquid solid content electrification and piezoelectricity. So previous number 5 is development how self-charging wireless sensor system of continuous operation capacity is made possible by such performance. Okay, this is my lecture review. Next is chapter 3. Okay, this is my flowchart. Okay, my flowchart is start with power supply to Arduino. Lepas tu next to display content display content such as this is my project. Okay, then apply the pressure of raindrop of piezoelectric to convert mechanical energy to electrical energy, then display voltage. That's mean how much the piezoelectric generate after use the raindrop. Then after that apply the bridge rectifier AC to DC, then supply to battery, start charging battery 12 volt. Then after at the battery, they go to boost converter to DC to DC to step up the voltage. Then go to load after that. And so next this is my block diagram. Okay, firstly piezo tie, then bridge rectifier AC to DC, boost converter DC to DC, then go to battery and 12 to go to load. After go to boost converter DC to DC, then go to voltage sensor, Arduino and LCD. So this is my build material. So I use piezoelectric plate 35mm, Arduino, LCD, bridge rectifier, boost converter, 5 volt dual charging port, voltage sensor, acid lead battery. So acid battery is a 12 volt. So 5 volt dual charge port ni, fast charging port is my load. Okay, this my schematic diagram. So this piezo material tie create the voltage cross piezo tie. So a bridge rectifier circuit produce DC voltage and give battery while charging the battery. Boost converter DC to DC is implement to hide the voltage. Then the voltage sensor link to boost converter and provide consistent voltage, and Arduino controller link to LCD display measure. So this schematic diagram. So this pull button is what apply while using a raindrop. This is a piezoelectric bridge rectifier, voltage sensor, LCD, Arduino, and this is boost converter. So next is chapter 4, preliminary result. So this is my simulation for boost converter. So this is schematic for boost converter, include power 12 volt, 12 volt. So they use the diode, MOSFET, switch device, DC voltmeter, and measure output. So this the calculation for boost converter. So this the result for boost converter. So at the 12 volt, they come out with a 43 volt, which means the boost converter come out with the high voltage. So this is simulation for piezo sensor. So I use push button, piezo, AC volt, Arduino, and virtual terminal. So after that, they're running simulation. Then I push the push button. Then when the push button, the LNF active the piezo sensor, because I have pressure up there. Lepas tu they generate the electricity output voltage. So at the simulation, the output for AC voltage is 3.82 voltage. So this I will testing piezoelectric using digital multimeter. So at the figure show, piezo sensor, I use 5 piezo tie for using the testing. The piezoelectric sensor require kinetic energy. So the second picture is piezo sensor press to generate the vibration and pressure to get the output voltage. So this is my data collection for testing piezo sensor. For I use the piezo sensor 1 until 5. The output voltage is for kalau 1 piezo is 0.067, 2 0.072, 3 piezoelectric 0.121, 4 0.134, 5 0.166. This I use the digital multimeter for testing piezo. So the conclusion for my project is the project must replicate an rectifier and booster circuit that integrate with the raindrop piezo generator. The piezo generator can be create the raindrop module and test the concept. This project was designed for human power energy collection application. This is power generator development project that generate energy through the piezo effect. Lastly is the device combine piezo sensor, Arduino, bridge rectifier module, and boost converter to improve system compatibility. This is my reference for reference for my project. This is my Gantt chart for PSM1. So this is define project title, project background study, literature review, source coding writing, schematic design, budget drafting, hardware setup, project finalizing, correction for submission, PSM1 report, prepare PSM presentation, report PSM1 submission panel, project writing report. This is my the green color is actual, the light green is my planning. So thank you for your attention. My name is Firdaus, and that's all.